So now that we've gone over how to do fractions like basic with numbers, we're going to go into algebraically, and we're going to do it in little steps. So first of all, we want to take an algebraic expression that is a rational, that is a fraction, and reduce it. Basically, those steps are going to come down to, for us, to factor and then cancel. So here's their first example. So we have 12 and 18. Now, normally we would divide these, say, both by the greatest common factor of 6, and we would get 2 over 3. But another way to think about this is to prime factorize the 12, which is what I'm doing right here. And I get 2 times 2 times 3. And then if I prime factorize the 18, I won't go through all the steps. We would get 2 times 3 times 3 like that. And then we cancel the things that are the same. Now, of course, we don't have to do, when we just have a fraction like that, we don't have to do that whole prime factorizing thing and do it like that. But that illustrates what we would do, say, for an example like this one right here. So we're going to treat the x's and y's just like we would numbers. So when we did rules of exponents, we did, like, if we're dividing, we subtract those exponents. So another way to look at this and to think about the exponents would be I'd have 5 x's at the top, and at the bottom I'd have 2 x's and 3 y's. And then if we if we cancel, we'd see that we cancel 2 of the x's and 1 of the y's, and that leaves 3 x's in the numerator, so x cubed, and 2 y's in the denominator. So we would then do the numerical part, and I would simply divide that by 2 and that by 2 and get 7 over 12 because 2 is the greatest common factor for 14 and 24. Now, another way to think about it is if we were to take a look at the exponents as in, rules of exponents, we would subtract those, and 5 minus 2 is 3, and we get x to the third. And there'd be a 1 here, and 1 minus 3 is negative 2, and then we would move the y down, and we would get the y squared. So that gives us this answer right here. So notice right here I say cancel, but never through addition or subtraction. So if I take a look at this example right here that just has numbers, we would add the numerator, get 10, add the denominator, get 23. I don't know why I wrote 12, 23. But here's some of the things that I've seen some students do. They take the 3 and the 9, and then they would do something like that. They would cancel those and get something like that, and then have 8 and 17. And I want to make clear, you cannot do that. You cannot do that. See, 8 17ths is not equal to 10 23rds. Those are completely different. You cannot cancel through addition or subtraction. So like if I take a look at this example right here over at the bottom right, here's that mistake with numbers. Some students would do that and cancel those and say that that's 9 halves, and that's not true. You cannot ever cancel through addition or subtraction. So what I just did at the bottom there with those two, you cannot do. That is wrong. All right, so let's take a look at some algebraic expressions here. So I just went over, we can't just cancel these x squares or these x's and treat each of these separately. We can only cancel, and this is very important, we can only cancel through multiplication. Okay, only through multiplication. So I'm going to factor this. So I'm going to factor the numerator, and I get x plus 6, x minus 3. I'm not going to go over how to factor. If that's something that you have trouble with, that's something that you should definitely seek help on separately. And we can factor this denominator and get x plus 4 and x minus 3. And now, even though we do have pluses and minuses here, we do see that it's actually this whole group times this whole group times this whole group. So since it is multiplication, now I can cancel whatever's in common. So I can cancel that entire group right there. And that's going to give me x plus 6 over x plus 4. And something that often we want to do with these is say our restrictions. And our restrictions are what our variable cannot be. Our denominator cannot equal 0. So our restrictions, we would say x plus 4 cannot be 0, which means x cannot be negative 4. Okay? So there's our simplification, and this is our restriction, x cannot be negative 4. Okay, so here's a simple algebraic expression. We can reduce the 16 and 12 by dividing those both by 4, because 4 is the greatest common factor for 16 and 12. So I'm going to get 4 over 3. And now as I look at the x's, there's an exponent of 1 right here, an exponent of 3. That's going to leave x squared at the top. An exponent of 1 right here. That's going to leave y cubed at the bottom. See, I just subtract those exponents. And there's more y's on bottom, so I'm going to have y's on the bottom there. And for restrictions, again, the denominator cannot be 0. So I'd say 3y cubed cannot be 0. So divide by 3, y cubed cannot be 0, which means if I do the cube root, y cannot be 0. So 0. Now, numerator can be 0. That's fine. If I had like 0 over 4, that equals 0. But if I have 4 over 0, that's undefined, and we don't like that. We do not like zeros in the denominator. Okay, let's go on. So what about this? Now, we need to remember when we're factoring that we first factor out the thing that's common to everything. So as I look at this numerator, I see that there's a y common to all the terms. So I can factor out a y. I also see that I could divide 21 and 3 by 3. So I'm going to factor out a 3y. That's going to leave on the inside here, if I do 3y squared divided by 3y, that leaves me with y. If I do 21 divided by 3, I'm going to get 7. Done. Okay, now at the bottom, see, y is not common to both of these, so I'm going to have to split up the group like this. So that's going to give me y and y. Y times y gives me y squared, and then plus 7 and minus 7. So if I do a quick check that that's true, my quick check would be y times y gives me y squared, gives me minus 7y, plus 7y, minus 49. That gives me y squared minus 49. So cancel those, and that gives me 3y over, well, what's left? The y minus 7. Now, what I was doing here when I was doing that, I was checking to make sure that I factored it correctly. All right, restrictions. What's the restriction? Well, this denominator cannot be 0, which means y cannot be 7. But there's our answer. Okay, the next one. So I can't just cancel out those x squares. I notice that there's no x in common to all of those. So I'm going to factor. Now don't assume it always factors, but in these examples they do. So I'm thinking factors of 3 that add up to a 2. And because of this minus, that means that I know that one of them is going to be plus, one of them is going to be minus. And since this is a plus 2, I know that when I think of my factors of 3, 1 and 3, 3 is going to be the positive one. And if I were to check that, I would get this. And at the bottom, I'm just going to jump to it. Now I look at this, and I ask, okay, is there anything that I can cancel? And the answer is, no, there's nothing that I can cancel. So don't assume that you can simplify all the time. It's just maybe. So let's say our restrictions, x cannot be negative 5 and x cannot be 3, okay, because the denominator cannot be 0. Let's change that problem a little bit. So I'm going to keep the numerator exactly the same. This is going to be like a totally different problem. What if the denominator, or actually, let's change the numerator. Let's say this was minus 2x, and we'll keep the denominator the same. So if this were minus 2x right here, when I go to factor, I'm going to get x minus 3 this time, and an x plus 1. And then when I factor the denominator, I'll have x plus 5 and x minus 3, now I can cancel those. And that would give me x plus 1 over x plus 5. And x cannot equal negative 5. Okay, let's try a more difficult example. So notice on this example, I have x cubed. But if I look at all the terms, do you notice there's at least one x on all the terms? So that tells me that I can factor out an x. So if I divide all those by an x, I've taken an x out, I get that. So always factor the common thing first, the common monomial. If I look at the denominator, look at 6, 18, and 60, I should think, now I don't like having a negative in front, I can factor out a negative 6. So that gives me x squared minus 3x minus 10. And now if possible, I'm going to factor that numerator a little bit further. Maybe it does, maybe it doesn't. When I think of factors of 12, I think 1 and 12, 2 and 6, 3 and 4, and I think, is there any sum of these that would give me an 8? And 2 and 6, 2 plus 6 gives me 8. So I have x plus 6 and x plus 2. Now notice when I write my factors, it's based upon that last term right there. All right, let's look at the denominator. So I have a negative 10 and a 3. So my factors of 10 are 1 and 10 and 2 and 5. And because this is a negative right here, I know I'm going to do a difference. So 2 and 5, if I subtract those, I do get a negative 3. So x minus 5 and x plus 2. Now what cancels? Well, the x plus 2's. So our final answer is going to be, and maybe I'll use a different color right here. I don't know what shows up. Maybe this red. Let's use red. X plus 6, and at the bottom, I'll move that negative out, so negative, and then x minus 5. Now, what's the restriction? So that cannot be 0. So x minus 5 cannot be 0. So x is not 5. And this is our final answer for that. Okay. So our denominator is partially factored already. So if it's already factored a little bit, then don't argue with that. Accept it. But it's not factored all the way. I could factor that x squared minus 9 a little bit more. So I will. So I have x minus 6, then x plus 3, and x minus 3. What about the numerator? Now, as I look at the numbers, I could factor out what's the common factor of 5, 20, and 15, and you should think 5. As I look at the x squared, or x cubed, x squared, and x, I could also factor out an x. So I'm essentially going to divide all these terms by 5x, and I'm going to get x squared plus 4x plus 3. And that will give me 5x, x plus 3, x plus 1, and x minus 6, x plus 3, x minus 3, boom, boom, those cancel, and that leaves me with my final answer of 5x all and x plus 1. Now we don't need to multiply that out. We could, but we don't need to. X minus 6 and x minus 3. And our restrictions. What are our restrictions? The denominator cannot equal 0. So x minus 6 can't equal 0. And x minus 3 cannot equal 0. As a step to all of these, you need to factor. So we're going to add the 6, add the 3, and x cannot equal those. So there's our complete answer. I know I'm going pretty fast through this, so this last question, I'll go a little bit slower. So I look at my numerator. I can't just start canceling things through addition and subtraction. I can't emphasize that enough. You can never cancel through anything other than multiplication. So what's common? You should think a 4. What else is common? I have a y in all of those. So a y. So that's going to give me 4y. Oh, not a 4. 4 divided 4 is 1. So y squared plus y minus 12. And at the bottom, I see I have a y common to all of them. Now I factor. So factors of 12. See, this is a minus. So when I think of factors of 12, I'm thinking, which of these factors have a difference of 1, 3, and 4? The 4 will be positive because I have a positive one right there in the middle. As I look at the denominator, I'm thinking of factors of 6 because this is a minus. I'm looking at the difference. So the difference of 2 and 3 is 1, but I want a negative 1, so I know that the 3 is going to have that sign. Now I look, what can I cancel? Hopefully you see these y's. Those y's right there, those will cancel. The y minus 3's, that whole group cancels. So what does that leave me with? Well, 4, y plus 4, and y plus 2. So we conclude y cannot equal negative 2, and this is our final answer. All right, hopefully that wasn't too fast for you, but basically you factor, cross-cancel, and then identify any restrictions that you might have.